Hi again, all you Java fans, all you Java developers. Welcome again to another talk, another session here. We have a really special guest and a special talk. As you see, guys, we have here some devices in the camera, and we are cooking a very wonderful stuff for you. Firstly, we would like to welcome our speaker, Frank Dilbert. Hi.
Hello, good evening, good afternoon, whatever.
Thank you so much for being with us here. Really appreciate your presence and your contribution to the jug world. Thank you so much. Really appreciate it.
With pleasure.
Yeah, so let's have a quick introduction about quickly what React Java User Group is. Like any other Java user group in the world, it's like trying to collaborate, invite the speakers, learn together, grow together. We are not really yet in person, but we are doing things virtually. So you can find all our recording sessions in our YouTube channel. It's Riyadh at Riyadh Jug. And also you can find us in LinkedIn as well, Riyadh Jug, and also on Twitter. We are not yet moved from Twitter to Sky Blue, so hopefully we're going to make it soon. A little bit about our speaker, Frank Delbert. He is a Java champion. He's a technical writer. He is a really author, a book author. He already authored a book on this topic. So yes, exactly. Yes. So we have the right guy talking about the right topic here. So we guys encourage you to have to collaborate also with us. If you have any questions, you find the box down. Please ask the questions that you have in mind. We will be like taking the questions in intervals. And also, if you want to invite your friends, please do invite everyone you like. So without further ado, let's welcome our speaker and Delbert Frank. The stage is yours. Good luck, and we hope
Okay,
to enjoy really this talk.
thank you. Thanks a lot. A good evening from, or good afternoon from freezing Belgium. So I heard it's a lot warmer on your side. Thank you for inviting me. I want to give you an introduction of what you can do with Java on a Raspberry Pi, why I think it's a great idea, and give you some examples. As you heard, indeed, I have a second camera here with a device next to me, and I will show you what we can do with electronics and Java. So I will show you how you can show, for instance, this beautiful heart at an 8 by 8 LED matrix, and you will also understand how this hex code is actually the representation of that heart. So what you need to uh, learn from bits and bytes to put some data on an electronic component, or like the clock display on the right, or the LCD display we have on top here. We will do that with a Vaadin application, just as a demo. There are different ways you can do this, but I really like this library, this framework, and I have an example that I can show you. Who am I? I am Frank, as you heard. I'm programming since the 80s. Yes, I'm that old because this was my first computer when I was 10 years old. And what we already did at that time was some kind of hackathon or LAN party before there were even networks as we know them now. And there's one special thing there that you maybe saw in the pictures, is actually that Commodore 64 at that time, I think it was better than the computers we have nowadays, and for one specific reason, and that is that you could attach wires to these computers, uh, on one side on the joystick port, and on the other side on an expansion port, and I could actually control different things around my computer. Like I was controlling my Lego train, and my computer knew where my Lego train was on the track because there was some magnetic sensors on the track which were connected to the joystick port. And instead of playing a game with a joystick, my computer knew where the train was on the track. And I could do that because those computers were very basic on one side, but the other side, they had a lot of connections around them, so you could control a relay board like you see here on the picture. And that was how I could control my train or change a switch or stuff like that. Um, Nowadays, I work at Azul as a technical writer. I have done Java development for over 15 years before joining Azul. You may know Azul from the different runtimes we provide of the Java OpenJDK and a specialized Prime version of it, and also Azul Intelligence Cloud, which offers extra knowledge and features on top of your running environments. Um, Most people know Azul from Zulu, which is a Java runtime, a build of OpenJDK, like you have many others. What is special about Zulu is that it is available for a lot of different platforms, also still Java 6, 7, 8 for people who really need it. But also it runs on the Raspberry Pi boards. And if you have older Raspberry Pis with an ARM v6 processor, those were the first generations of the Raspberry Pi, Azul has a version of Java 8 and 11 which still runs with up-to-date versions on these boards. So as I said, we also have Zing, which is another build of OpenJDK, but has a different garbage collector, a different compiler, and this is used at a lot of companies with high demands, with high performance, where they need high performance. And for instance, you can get a 20% performance gain without changing anything in your code, just changing the runtime. You may also heard of Azul related to Crack, which is a project which is now already a few years being developed. And it's about improving the startup time of Java applications. With our first tests, this is a screenshot of a table which was part of the very first release notes. We could improve a Spring Boot application startup time from 4 seconds to 40 milliseconds by using Crack. So it creates a checkpoint at some point when your application is warmed up, and it can restart from there. And as I am speaking about Java on Raspberry Pi doing experiments, I also have been experimenting with Crack on a Raspberry Pi. If you want to know more about that, check my blog. It didn't work initially, but there were some changes in the operating system for the Raspberry Pi and also in the Crack runtime and library, which made it work on the Raspberry Pi. So even that kind of experiments can be done on a Raspberry Pi. To be clear, what is a Raspberry Pi? Most people will know it as the B version of the Raspberry Pi board, but actually there are different types of Raspberry Pis. The A board has less connections, so there's no network connection there, only USB. So it's a bit cheaper. So for some use cases, this is a perfect solution. Then the B board is the full option, let's say, with even 2 HDMI connections on the latest boards, different USB ports, stuff like that. Then you have the Zero, which is really a very powerful computer. It costs between 15 and 25 euro, depending on the version. It has Wi-Fi. And yes, you can run Java on a Raspberry Pi Zero. I have done that a lot. I'm using cameras even which are controlled by a Java application on a Zero. It has only a half a gig of memory, but that's more than enough to run even Spring on it or do some testing. So yes, you can run Java on all these. The compute module is a special one. I will come back to that a bit later. The very first Raspberry Pi appeared in 2012, so a lot has changed. We are now on the 5th generation of these boards. Initially, these Raspberry Pi computers were aimed at people who didn't have the budget to buy a full-blown PC. So the idea was most people or all people have a television, at that time analog televisions. So let's build a computer that you can connect to an analog television, so they had an analog video output, and then see what we can do with it. And that's how this whole movement actually started, of people making all kinds of applications and devices on top of these boards. And then yeah, the latest generations, they have a lot of power in them. The prices went up quite a bit of these devices, but this is taken from a video from Jeff Gerling, who creates a lot of content about Raspberry Pis. He compared it with, yeah, what you can expect if you follow some curves. Um, a Raspberry Pi 5 was launched with 16 gigabytes of memory very recently, but it still follows that logical graph of the price that you can expect from a device like this with that amount of memory. So I can imagine that business is going good at Raspberry Pi company, but still they are not milking it, like you could say, but really building a great product for a reasonable price. As I said, you also have the compute board, the compute module actually. What's the idea of the compute module? It exists in also different versions, so compute 3, 4, and 5. It's actually the same processor and memory and peripherals as the Raspberry Pi 3, 4, and 5. But it doesn't have any connections like USB, network, HDMI. On the bottom of this board, there are two long connectors with a lot of very small pins. So you have to click it on a baseboard, and you can find different baseboards, existing baseboards. Like the one you see now is aimed to be a NAS or some kind of network device. It has 2 network connections and 3 USB C connections, so high-speed USB connections. But the idea is, if you need a computer that you need to build into a device that you're creating yourself, you can actually use a Raspberry Pi compute module. It has the system on chip, it has memory, it can have Wi-Fi if you need it. And you just design the baseboard for it with all the connections you need for your project. If you need a network connection and 1 HDMI, you can add it to that baseboard and wire it to the compute module. So a very powerful device. It's available in different flavors depending on the amount of memory, the amount of OS storage, with or without Wi-Fi. So you can have a wide range. I think it's between 35 and 95 euros, something like that. So different flavors. I think there are about 12 of the Compute 4, for instance. It's very small. It has the size of a matchbox, and yeah, you can build it in whatever kind of device that you are building. 2 special types of Raspberry Pis is the 400 and the 500. Again, they are based on the Raspberry Pi 4 and 5, but they actually build it into a keyboard. So you only need this keyboard, a connection to a screen, a connection to a mouse, and a power supply, of course, and you have a computer. So everything which is part of the computer is inside the keyboard. So you see the same connections like you have on the Raspberry Pi 400, a few USBs, 2 HDMIs, the 40-pin connector are here inside the keyboard. So below 100 euro, you have a full computer built into a keyboard, and last year they announced the Raspberry Pi 500. And yeah, this brings me back onto memory lane, or how do you call it? This is exactly the power of the Commodore 64, which is returning now to nowadays computers. So a very powerful Raspberry Pi 400 or 500, but you have the ability to connect stuff to it. Electronic components, interact with physical things from your software, and have this interaction between software and hardware. I need, for completeness, I need to mention the Raspberry Pi Pico, which is a microcontroller, so it has absolutely no connection with the other Raspberry Pis that are already mentioned. So this is more comparable to an Arduino or ESP32. You also program it differently. The use case is completely different. This doesn't run Linux. This is a microcontroller. Can do amazing stuff with it. They only costs 4 to 8 euro, I think, but it's not the same kind of product as the other Raspberry Pis. So the Raspberry Pis I'm talking about, it's a single board computer. You can install an operating system, a full Linux server or desktop environment, so either with a terminal as an interface or with a graphical user interface. You have a lot of OS versions available, both in 32-bit and 64-bit. 64-bit is the way forward for the latest boards. Raspberry Pi has their own operating system based on Debian. They keep it updated, a lot of evolutions there. You can update it continuously, taking advantage of all the changes which are in Debian. But you also have other flavors. You can run Ubuntu. You can find operating systems which are a NAS or a media center, or with a lot of retro games, so that you can make some kind of arcade cabinet with retro games in it. So all that kind of operating systems is available, so that you just burn it on an SD card, put the SD card in your Raspberry Pi, and you have your system up and running very fast. The Pis are made in a Sony factory in England. And Jeff Gerling, again, the same guy, he had a tour. He got a tour in the company, and he has created an amazing video showing how they make them. It was at the time that they were producing most Raspberry Pi 4s with a lot of robots. The Raspberry Pi 5, which is a lot of changes in hardware and what it can do. It also has a lot of changes in the type of components, so they need less robots and they can produce more of them faster and cheaper. It's all part in the video or in the comments. Definitely check it out if you're interested in seeing how they build this kind of devices and keep them as cheap as possible. Now, I already said a few times, connecting physical things to the Raspberry Pi is the real power. And that's thanks to this header. So these 40 pins, the header of the Raspberry Pi, allows you to communicate with electronic components. And actually, this bit of fun story here is when they were designing the very first Raspberry Pi, the system on chip, so the CPU, the little gray box here on the slide, they had some of these pins left over, so they were not using them, and they thought, yeah, let's just bring them outside of the SoC and let us add a little header. I think they only had 8 or 26 of these pins in the very first Raspberry Pis. Let's just add them on the board. We'll see what we can do with them later. And actually, these pins have been the driving force of what you can do with Raspberry Pis. They have been the big driver of makers using Raspberry Pis to build amazing stuff. It's because you have this header, and that's also why it has grown from 8 to 26 to 40 pins now. So you can connect a lot of different devices to build stuff on there. I see a question about production-ready applications. We'll come that later. Now, how did my journey start with all this Raspberry Pi stuff? It's actually 5 years ago. I was building this application for my son, for the drum boot of my son. And I wanted to have this touch-based user interface using JavaFX that I already know, Java to control everything, and an Arduino. So everything here can be controlled with Java. And of course, because it's a Java application, there is an API, and from anywhere else in the house, we can give him the red light signal that dinner is on the table and he has to come down. By the way, this video is 5 years old, so that little boy that you just saw in the video is now a very big guy. So I need to update this video. Now you may wonder why I decided to build this with Java, because Raspberry Pi, the name Pi comes from the number pi, but also comes from Python. They were designing the Raspberry Pi as being a device to learn how to code with Python, and they also made it easy to use Python and interact with electronic components. But I knew Java and I wanted to learn something, and if you want to learn something, you should focus on one thing, and the thing I wanted to focus on was the electronics. How can I control electronics? What do I need to learn? I had been experimenting with electronics when I was a teenager many years ago, so I lost that knowledge. I didn't use any electronics protocols and how to communicate with electronic components in my career. So that's what I wanted to learn. And for the next 6 months, this was my companion. And I started with one component, a LED. Let's blink a LED, the Hello World application of electronics, blinking a LED. Let's try that. And it took me days before that LED got blinking, because I had to learn how to put an operating system on the SD card of a Raspberry Pi, how to install Java, which version of Java, actually how do you control a LED and stuff like that. So I started writing down what I learned and started blogging, put it on my blog, on other blogs, wrote an article for a magazine. And from all those articles, I eventually ended up with writing a book. So all these experiments helped me to become an author. Yeah, Morse code is definitely a nice use case here. This book helped me to describe what I learned. I hope it also inspired others. It was published as a paper book. So you see one behind me. Those 1,000 copies are sold out. A bit lucky because, of course, Java evolved and all the libraries that I described evolved. So I'm updating the book. Update 2024 is already outdated because I have an update 2025, which describes the new Raspberry Pi boards, and I will also publish new versions this year of the ebook. So the ebook is constantly updated. If you check this link, you will find the book. You can buy it on Leanpub, but whenever I need publish an update, you will also get the new version of the book. And it has a lot of examples of everything that I'm showing here, but a lot more. Now, the main thing that I discovered and learned while writing the book is to use Pi4J. And Pi4J is a library, a friendly object-oriented I/O API with libraries for Java programmers to access the full I/O capabilities of the Raspberry Pi platform. So the idea is that you can focus on implementing the application business logic. You don't need to worry a lot about how an electronic component needs to be controlled. If you select the right way of talking to it and provide the right values, then Pi4J will help you a lot to achieve that. How it works is that Pi4J is a dependency you add to your Maven project or Gradle project. You have some code that you can use there, APIs. Inside the library are native libraries, C code, C++ code, which can interact with the hardware interfaces and all these different protocols which are used there to control these GPIOs. So it is a library, a Java library, and that brings me back to the question of Jack Sparrow. Oh, Jack Sparrow, we have a pirate in the room. What is the best practice to build production-ready applications and devices? Because it's Java, and you can run Java, any version of Java on the Raspberry Pi, it is the framework that you love and already know. being Spring, Quarkus, Micronaut, whatever, it can run on a Raspberry Pi. There are people experimenting with Kubernetes clusters by combining 3 or 4 Raspberry Pis. You can do that. So everything you use in your company as a production ready system can run on a Raspberry Pi. I don't say that you should use Raspberry Pi servers in production, but it's ideal for testing. And if you have a small sized application, it can definitely run in production on a Raspberry Pi. So which frameworks? Any framework that you love and that you can use and know how to use it can run on a Raspberry Pi. So while writing the book, I got into contact with Robert Savage, who created Pi4J. He is now no longer actively involved in the project. He has a lot of other projects he's now doing. But with several people, we joined this project. I focus on documentation. And we have several people within the team now doing improvements and adding functionality. At some point, Pi4J was not usable on the new just launched Raspberry Pi 5. Then we had again someone joining and saying, yeah, I know how to fix this. I will handle it. He made a pull request. And very quickly we could integrate as a way of adding compatibility with the Raspberry Pi 5. What we last week did, exactly 1 week ago, we bumped the whole project to Java 21. So we were basing on Java 11, but we want to proceed. We want to make use of what's coming into Java. So all these new features that are coming in Java with all these 6-month release cycles, there are a few things that can definitely help us to make Pi4J better. And one of them is JEP454, Foreign Function and Memory API. That will make it a lot easier to interact with C code, with native code. And that's exactly what Pi4J is doing. It's using native code to interact with the GPIOs. Robert von Burg, Robert Eich, he created an example based on Java 22 because this JEP454 is only available in Java 22. Why didn't we jump to Java 22? Because it's not a long-term support version. Maybe that's not bad to use it on a Raspberry Pi, but because in production most companies stick to LTS versions, that's also what we don't want to do with the library. So we now bumped it to the latest LTS, which is Java 21 at this moment. That means next September we could, if you want, jump to Java 25, and then we could make use of this new JEP. But of course, there has been so much changes in Java that we could actually go back to the code and improve it a lot, use lambdas in a better way, the new switch case things that have arrived. So we could actually make the code cleaner if we want to do that. By the way, please go to pi4j.com, the website, if you're interested in everything which is related to using Java on a Raspberry Pi. So you don't need to use Pi4J. You will have everything here to install Java on a Raspberry Pi. So all the info is here. We have some getting started. If you follow these steps, you will actually already learn a lot. We have example implementations with GBang. If you don't know GBang, that's a great way to have everything in one file. So even dependencies. And you can execute this with GBang and you don't need a full Maven or Gradle project. So it's ideal also to learn stuff like this. So check out the GBang examples if you want to get started quickly with Pi4J. And then there is a blog post about what we have changed in the project regarding Java 21. Another side project or part of Pi4J. So inside Pi4J, the library, there is a database with all the Raspberry Pi models. So We are exposing that at api.pi4j.com. So this makes use of Pi4J, the library, but again, this is a Vaadin application. So here you have all the Raspberry Pis. You can see, let me see if I select the Raspberry Pi 5. So these 40 pins header that you have there, what kind of signal do you have? Is it an input? Can you use it as an input output, or does it have a dedicated use like serial communication or SPI or I2C? So all this kind of information is here. And of course, because we are a Raspberry Pi project, this system is actually running on a Raspberry Pi. So what you see here is a Vaadin web application. So again, going back to what frameworks can you use on Raspberry Pi? All of them. So Vaadin is here used to create the web UI, and it runs on a Raspberry Pi with a Java runtime 22 of Azul, of course. This is a full system being hosted by, let me see, Final Tech is the company. Yeah, we have Swagger there. We have JSON output. So everything you expect from a Java API application. The code is on GitHub, of course, and it's running on a finaltech.com Raspberry Pi in a data center in Czechia. So everything Raspberry Pi from the beginning, from the code to what you see here. Now, as I said, blinking a LED, the Hello World type of application in electronics. So this little project, the minimal example, which is described on the Pi4J website, actually goes a step further. It also has a button. So it has an output being the LED, and it has an input being the button. And in this example application, if you click on the button, the LED blinks a bit faster. If you've clicked the button 5 times, then the application stops. So that's the minimal application that we use in different examples on the website. And blinking a LED is actually very easy because it's a Java object. So your LED becomes a Java object. So what we need to know is the pin. Where is it connected? If we go back to the API here, so board Pi 500. So we are on BCM22. Where is it? Here, BCM22. So there are some different numberings used in these pins. BCM is some kind of standard. So it's the actual physical pin 15 that we are using for the LED. And we need the context. The context is Pi4J loads all the modules that are part of the library and that you included in your jar or in your project. And it will check on which board it's running, because a Raspberry Pi 5 needs another implementation than a Raspberry Pi 4. So it will select this for you automatically. That's something we added very recently. And then you can create, within this context, a digital output. And the only required thing here is which pin will be used. Where is the LED connected on which of these pins of the Raspberry Pi? So now we have a LED, which is a Java object, which we can control with Java code, but it's actually linked to a physical LED. And in here, we can just blink it every half a second, put it on or off. So we actually toggle the Java object from low to high, which is either 0 volt or 3.3 volts. Do I need to have any experience in electric circuit? No, because I had very limited experience. They say you have to be careful that you don't fry your Raspberry Pi. I've done a lot of experiments, I've done a lot of things wrong, and I didn't destroy any Raspberry Pi. The only things that I destroyed were a few LEDs and a few of these clock displays, so which are very cheap, by the way. So you don't need any experience. If you follow a lot of these tutorials or follow my book, it will all be explained. Like for instance, the LED, it has a positive side and a negative side. If you turn it the other way around, it will not do anything. So you have to put it in the right direction, but that's also described. And then you get something like this. Don't mind the very fancy cooler on top of this Raspberry Pi. I am an influencer because I got this fan for free because I was writing about Raspberry Pi. That's one of the only things I ever got. But you see here, by clicking the button, the LED blinks a bit faster. In the background, you see the log output of the Java application. Exactly the things we do in production. So we have a log output, SLF4J is used here. You see you have a few wires here connected, a few resistors. Even it works without resistors, only the LED is blinking, is a bit brighter then, and it could burn if you put too much voltage. It depends a bit on the color of the LED. But don't be afraid to start experimenting with electronics, definitely. Now, I said in the beginning, let's build something more complex. And we're going to use the Elcro. So that's the one, the device next to me. You see on the screen that there are different versions of this. I'm using generation 1 with the smallest screen. Generation 2 has a keyboard. All the components are below the keyboard. But anyhow, this looks exactly like a bomb would look like in a movie with a countdown timer and stuff like that. So be careful. I've never taken this on a plane in my hand luggage yet. I don't dare to do that. But this is a really nice device because it has a lot of the basic components which are used in every starter kit. If you buy an electronic starter kit, you will have some LEDs, an 8x8 LED matrix, an LCD display, buttons, buzzers, stuff like that. Everything here is already pre-wired in this little suitcase. You add the Raspberry Pi of your choice. I think I have one here with a Raspberry Pi 4. So you have a bit the freedom there, depending on your budget, if you take one with a lot of gigabytes of memory or the smaller one. You have to fix it in here. There is a connection here with this cable, and then you can control all these components. And if it doesn't work, then most probably it doesn't work because of your code, not because you did the wrong wiring, because it is already wired. And that's why this is a very nice experimentation kit, but there are more like this. Thanks to students of the FHNW University of Switzerland, we have example code for all the components in this Pi1. So everything components you see here, you will find example code on the Pi4J website with a link to this GitHub project. And that's exactly what I've done. So I've taken existing code and used it within my application, which is, so this is the Pi. You see that they have example app, then a humidity and temperature sensor, infrared receiver, LCD display, 7-segment app, and so on and so on and so on. So for every component, they have an app. So you can start this application, select a number from 1 to the number they have, and it will control the display. So this is how the application look. If you start it, then you select a number, for instance, number 8, and it will do something on the LCD display. So it's an example application. It just puts some hello world text on an LCD display and stuff like that. I combined it with Vaadin. So if you don't know Vaadin, it's the very best solution to build web user interfaces with purely Java. You can write a complete UI in Java. I really love it. I'm a big JavaFX fan for graphical user interfaces, desktop applications. Vaadin is the best thing in the web. It allows you to build very powerful applications within a Spring framework, a Spring Boot environment. And in pure Java, you can create an application, and you can create your start application here on start.vaadin.com and download a full Maven project to get you started immediately. So within my demo application, I'm using Pi4J, of course, and I have several components that I can control. So I have a LED as a digital output, simply turning something on and off. I have a touch, which is like a button, a digital input, just putting something on, reading a state of is it on or is it off, is it pressed or is it not pressed. And then you have other protocols being used, which are very common in electronics, like I2C, SPI, pulse width modulation, PWM. So all these are used to control, for instance, the LCD display, the 7-segment display, a LED matrix, the buzzer. So all these are controlled from that Vaadin application. Now, what we do need to understand are bits and bytes. So when I started doing this, I was doing web development before that, and I knew FF is red, 00 FF 00 is green, and the other one is blue. But what do these values actually mean? Do you all know what are the bits behind it? Because we know that the computer only works with ones and zeros. And actually there's a lot we can learn here and use for other ways of handling data. So FF means we have 8 bits which are on. So we have 8 true false values and all are true. And if you have followed some IT course, or if you followed electronics or whatever, you know how this works with the power of 2 and how you calculate these values. I like to explain it with a movie I found online, which visualized this very nicely. So this is a fun weekend project if you want to build something with your kids and you want to learn them how to convert bits and bytes, vice versa. This is a very nice approach. So this only has 6 bits, but there are normally 8 within a byte. And we can do some amazing things with it, because if you look at this electronic component, for instance, it's called a 7-segment display because it has 1, 2, 3, 4, 5, 6, 7 segments, but then the 8th one is the dot. So actually we have 8 LEDs here that can be turned on and off. So again, 8 LEDs, 8 true false values. That means with 1 byte, we can define what is shown on such a little display. Yeah? So let's use the 6D, hex 6D, for instance. I can now challenge you all to convert this to bits, but that's what it looks like. So from this 8 true false values, this is the representation of what is 6D. Now the 6D is the value that you need to put a 5 on that display. Okay, so with sending a 6D value to this, to the controller of this 7-segment display, it knows that it has to show a 5, 6D, 1 byte. Okay, if we would do this with XML, then we would need 345 characters to send exactly the same data needed to show this 5. Huh? And this is what we're doing the whole day when we're using APIs and sending data between Java application or other types of applications. We are using XML or we are using JSON. Huh? Same problem, 250 characters to send something which fits into 1 byte, into 1 number value. YAML, even worse. Huh? It's not readable even, and you can make typos, so never use YAML. Huh? Let's agree on that. This is how the setup looks like I used in my book. It's a bit complicated, and that's because the Raspberry Pi has a lot of GPIOs, so it definitely has 8 GPIOs that you can use to do this. I use the chip in between, and the chip actually converts the 6D into what should be on this little display. If you like electronics, this is another way of representing it. I only added this image so I can show you that I can draw an image like that. It doesn't mean I understand it fully, but it worked in my example. Okay, let's go into some of the code. So this project is available on GitHub. It is that Pi4J Vaadin application that you will see in a moment on the Raspberry Pi itself. So it has, this is how you in Vaadin define your pages. So I have different pages with just the info about Pi4J, about the system it's running on. But then I have a screen to toggle a LED, to put some sound on a buzzer, to interact with the touch. So all these are here. And if you're familiar with Spring Boot applications, then you know that you can use a service, a singleton, and this service is the one that actually interacts with the electronic components in this test setup. So again, I have a LED on pin 22, I have a touch, a button on pin 17, and then some other things. I'm defining the LCD display. So everything here is initialized in separate methods. If you want to reuse something from this code, then you can just take the portions you need for the experiment you want to set up. So I init a LED, so I use some more configurations here. This is more, it's not really needed. It just shows you what you can define as initial values with the builder pattern. We do the same for the touch and so on and so on. If you look into the 7 segment component, it extends from another class which contains some more information about electronic devices. So those are the things I've taken from the CrowPi example project that was created by the students. So it's a mix of code I just copied. I'm a full stack copy developer. And I added some stuff here. So, and here you can add some symbols. And if you look at the symbols, like putting a 1 on that 7 segment display, that means that the top element is on and the left top and the right top and so on and so on. So different ways of defining these hex values. You can probably also see that in the heart. So remember that very first slide I showed you with the heart being displayed, actually drawing a heart. You can see it here is with all these hex values being, this is a full row and this is with less LEDs and so on and so on. So this whole code is here. It's free for you to check on GitHub and see what it actually does. So let's go to a demo. So this is now the running application. Now, what you see here is the application running here on this device. Okay, we can see that because it's running on a Raspberry Pi 4 Model P, and it's running on Java 22 Azul again. And this is the libraries it has loaded and stuff like that. So some extra information. The touch sensor was initialized, and then the LED is somewhere here, I think, the LED. So everything which was initialized at startup by this Pi4J service, this within the Spring Boot framework. We have some info here, but that's not important. Now let me first zoom in a bit and try to show you a bit more of the device. Okay, good. The LED is very small, so you see here there are already a few LEDs on. Now if I toggle this on the UI, you will see that there is a red light here. It's very small, I know, so that's not that impressive, this demo. So let's move on to the touch. Here this little circle is a touch sensor, and you see as soon as I put my finger on it or release it, that the UI gets updated. So this is also one of the strengths of Vaadin. There is some methods available there to interact continuously with your UI and update it as soon as something happens in your code. The LCD display, so that's this one. So now it shows you hello Riyadh, so I can just clean it and then put hello, oops, and then world on it. Okay, voila. You see here what has happened. The same goes for the LED matrix, so that's this one, 8 rows of 8 LEDs. So again, 8 LEDs, 8 true false values, means 1 byte. 1 byte defines all the LEDs that's on one row. So if we go to a smiley face, then you see 3C is actually these 4 LEDs which are on. And if I pick one, is there one with an empty row? I don't think so. No, but yeah, there are a lot of here. I can move this, and that's just actually moving data in an array, which happens here. Okay, and then the 7 segments. So I have 4 of them here. Can clear it again. I can put a value here, and you see, so if I select the 5, then you see that we are again at the 6D value that I showed you before. Okay. Now, the fun thing is, let me try to get a few things on the screen at the same time now. So what you see now on the screen is what's happening on this Raspberry Pi. So this is the output of the Spring Boot application, so just the log, whatever I've done here. So we have put the number 5 on position 1. This is my tunnel. This allows you to connect to my Raspberry Pi in a moment. And this is the BTOP. BTOP, a very nice visualization of what's happening on the board. So this is a Raspberry Pi 4. It has 4 cores. It has only 2 gigabytes of memory. It's now running the Spring Boot application. And now I invite you to join this demo. And you can join it by going to pi4j.ngrok.dev, which is this tunnel here, which is provided by ngrok. I hate setting up firewalls and the routes and stuff like that, so it actually works the other way around. You start something on the Raspberry Pi and it makes a connection to the outside world, and now you can, through this link, access this Raspberry Pi. So I'm wondering if people are now trying this out and see what's happening. And then we would see some demos. I have no idea how many people are watching this live stream. So this will only work during the live stream. If you're watching this recording afterwards, nothing will happen, of course. I see I have some open connections, so I don't know if people are experimenting already or opening it, and you can see and test it out. I can, by the way, test something else myself. I didn't show this yet, which is the buzzer. So there's also a buzzer here. I don't know how well you will hear it through my microphone, but this actually makes a sound on the device. If you are connected and trying out the UIs, I see I have 5 open connections at this moment. Don't be afraid to just try whatever you want and put it on the screen. Hi from Lima, Andres. So you see, again, what can run on the Raspberry Pi? Anything, and you can just make it accessible just like you would do with any other type of application. For the people who are now connected and have the UI open, if you go to the screen with the touch event, you will all see at the same time that I click on this sensor, so the data is sent back to in your direction. Okay. Andres Alcara, your name is now completely on the screen. Okay, back to the presentation. We're nearly at the end and the end of the time, so that's perfect timing. If you want to learn more about this and about anything related to OpenJDK, Java, Kotlin, developer best practice, whatever, please visit 4j.io, which is a website. I also contribute a lot of content. We also invite you to become an author if you have anything article related to Java or OpenJDK that could be interesting for the community. My posts related to Raspberry Pi electronics or experiments with JavaFX, I also publish them on Pi4J, so you'll find a lot of articles there if you look for Pi4J or any other topic. And I also have 1 or 2 times a month a podcast about anything related to Java or what is happening in the OpenJDK world. So I also invite you to join my podcast. And if you have an interesting topic to discuss, also please let me know, and maybe you will be a guest in one of them the next times. What's next? So, of course, if you want to learn more, there's a great book I can advise you to buy on webtechie.be/books, the ebook, and I promise you that you will get a new version somewhere in 2025, I hope as soon as possible. With the newest Pi4J library, there are a lot of examples I can update, and I will update because, yeah, Java evolved, the libraries evolved, so there's a lot you can do. There are examples there with Spring, with mosquito queues, LED strips, Arduino sensors, and showing it on graphs, so a lot of examples there. You can follow me on Mastodon and on Blue Sky, on LinkedIn, and if I tweet something, you can read it on Java on Raspberry Pi as the hashtag. And I have great session. Thank you. That's what I have on the message on the screen now, and a heart. You can visit webtechie.be, Pi4J.io, and pi4j.com to learn more about all the topics I discussed here. And I invite you to experiment, fail and learn, and definitely repeat. That's what I've done while writing the book and learning about all these. And failing is not bad. Either you learn something or you achieve something, and definitely that's what happens when you experiment. And as I said, you won't break a lot of stuff. The only things I broke were a few of these little displays and a few LEDs, but the Raspberry Pis all survived my experiments, and I hope you have fun while doing so. That's it. Thanks for joining, and maybe you can check if we have some questions remaining. What?
Yes, thank you so much, Frank, for this great talk. There are some questions in my mind, if you don't mind.
Yeah, no.
Now, how can we relate the Internet of Things with this Raspberry Pi? Is there any relation, or this is completely different topics?
It depends what you define as Internet of Things. For most people, Internet of Things are small sensors. So like a temperature sensor, and then you would use something like an ESP32 or the Raspberry Pi Pico, a very small device, which does only one thing. It reads the sensor and sends it out to a queue or whatever, like I did with a mosquito queue. For other people, Internet of Things it ends at an edge device. And an edge device is like, for instance, a Raspberry Pi with a bigger application, like a Vaadin or a Spring Boot application, where you collect info from different sensors and you pre-process it before you send it to a bigger server. Like, for instance, you have a temperature sensor or a lot of temperature sensors in a factory. In the edge device, you gather all this information and you decide which ones are important to send to the backend. So where does Internet of Things end? It's a discussion. But definitely Raspberry Pi has a place there, because it can be an edge device or it can be a tool to gather information. I just published a very nice example on the Pi4J website, the Smart Coop. It's someone who built this. He built his own hardware device with a Raspberry Pi Zero, and it is to control 30 chickens in his garden and open gates and see if there are no foxes and stuff like that. So is this Internet of Things? Yes, but
Yeah,
it goes way further than just a sensor or opening a door or something like that. So this is a really fun project. We have other projects like this on the website. Um, so yeah, it's Internet of Things, but how small a thing is open for debate.
yes, indeed, indeed. Yes, it's pretty clear now.
Yeah.
And about like from your past experience or your experience, do we have any like production examples, live examples where Pi4J is using within the Raspberry Pi?
Um, we have a few examples here on the website. As with most open source projects, we are being used and not told about it because people are afraid that they should pay
Uh,
for support, probably. But uh, Robert von Berg, who is one of the main contributors, he has a company in Switzerland and they build this kind of things. So they handle the pharmacies in hospitals. So they have to distribute for medicines and stuff like that. And they have this beautiful device, this cabinet. And if you start picking medicines for a patient, it says you have to pick this from drawer one, from this box. And it lights the box in green. And if you put your hand in the wrong box, it turns red. So it helps you to pick the right medicines. And this is
mm,
controlled by a Raspberry Pi, which is connected to the backend of the medicine system and stuff like that. So this is something which is using Pi4J in an industrial environment. There are others. There are definitely also fun examples like the street robot, which is part of a street theater act, which is again controlling LEDs and stuff like that. So uh, Java on Raspberry Pi is a bit controversial. A lot of people say it's a very small niche. It is a small niche, but actually, because Java is so powerful and you have so many amazing libraries to do amazing stuff like VAD and like I use a lot of JavaFX. I don't know if you can see it. The screen behind me is for the drum boot of my son with this touch thing, so it's a new version. Um, very nice user interfaces with JavaFX. And you can all do that thanks to this community who is building all these libraries. And Java is so stable, so I can use Java 8 if I want, but I can also jump to the latest version and I have all these extra improvements in the language and in the runtime and use less memory. So why not Java? It's a
yes,
it's a perfect language for what we do professionally. So why not also use it for this kind of things on small PC? By the way, the latest Raspberry Pi 5 is pretty powerful. A it's a little server on a little board, but it's actually very powerful.
amazing. You know, there's like the common saying about Java is Java for the web. So once we see Java in devices, we see something. Why Java in
Yeah.
devices? It's in the web. It should be in the microservices. It should be in the API.
But
So
what
this is
people
the
forget is that that's where Java was born. Eh? Java was
yes,
born
exactly.
in set-top boxes, in multimedia devices, in cars, in fridges. At that time, they wanted to build fridges with screens with Java. That's where Java was born. It was the first operating system for mobile phones with touchscreens.
Yes.
Indeed, nowadays, and that's a bit what Oracle decided, is we go in the direction of server systems. So that's also why they don't put a lot of effort in JavaFX. They're still the driving force or one of the driving forces in the JavaFX development, but Oracle has chosen the path of where the money is. The big companies, server side things, cloud applications. But that's where Java was born and where Java still is very performant and can. Um, I don't have the slide in my presentation, but there was some research projects about the energy efficiency of different languages. And then if C is the benchmark, then Java needs about 2 times the same energy for the same kind of function as C. But if you look at
Mm,
Python, it uses 78 times the energy of that C. So our Java is already much more energy efficient. So again, going back to the total cost of your applications, your production system in the cloud, it can do a lot more for a lower price because it's more energy efficient. That means that you need less servers. So why would you do something in Python if already that is such a big advantage? So the same goes for the Raspberry Pi. It needs less energy to do more. So why not?
Yes, that's really very, very logical
Yeah,
answer.
yeah, yeah.
Amazing. Yeah, yeah. Thank you so much, Frank. It's really a very, very enjoying session. For me, it's the first time really I'm exploring the Raspberry Pi and exploring this sort of
Yeah,
devices.
yeah.
It's really amazing. I really enjoyed it.
And it's amazing, and you can get started. So if it's your birthday or whatever, ask for a Raspberry Pi, and the second person that needs to buy you a present, ask for an electronic starter kit. You have them from 20 to 30 euros, and it has all these components that is inside this Grow Pi, like LEDs, this LCD display. For 30 euros, you can get a whole box full of these little components. And as someone said, not just hook them up, first look it up in the documentation. But for all these kind of components, either in my book or on Pi4J or any website, you will find how to connect them and how you can control them. You will definitely need to search for it and experiment, but it's such a fun way to learn new things.
Yes, thank you so much, Frank. Here we are ending the session. If you
Yeah,
have
over
any
time.
final, yeah, yeah, if you have any final words to say before we end the session.
uh, in, Look at pi4j.com if you want to learn more, and you can also find me somewhere online, and I can also help you if needed.
All right. With this being said, please go and check the Pi4J online, and please look also Frank's report book. And we say thank you so much, guys, for joining us, and we hope to see you again in another talk, another session.
Yeah. Bye.
Goodbye.
Thank you.